Hi, my name is Anshu and welcome to my channel Bottleneck. This is a data structures and algorithms series. In our previous video, we learned about what is dynamic programming, how it is different from divide and conquer, and what are different approaches to dynamic programming. We also implemented Fibonacci series using a recursive solution. Now we also we did a data walk and traced the data to see how it can result into stack overflow or out of memory error. Alright. In this video, we are going to implement one of the solutions or one of the dynamic programming approach, that is top-down approach. And we will be doing it using Scala functional programming. Alright, so let's write the method. So it's going to be Fibonacci and top-down. Let's name it as top-down approach. Alright, so this is going to be int to int. Okay, so it is going to take a value as int and it is going to return a value as int. So the input is n, alright, which is type of int, and the body of this method will be same as before. If n equals to 0, it is going to return 0, else if n equals to 1, it is going to return 1, else, okay, watch closely how I am writing it. So it is going to be 2. So we already did 0 and 1, now it is about 2, 2 to n, alright, and we are going to implement fold left. So we are going to iteratively move on from 2 to n and we will accumulate the results. So we are using fold left. So it is going to be a sequence and the input value will be 0 and 1. And we will provide an anonymous method which will have an accumulator and the index. And we are going to add on or append to the accumulator every time we iterate. So this is purely functional. So in every iteration there will be a new ACC created and it will be passed on to the next following iteration, and this is how it is going to be. Again, same formula is going to be used, fn minus 1 fn minus 2. All right, so it's going to be v minus 1 plus ACC v minus 2. All right, and now it creates a sequence of int, but we are interested in the nth element, so we will use the last. All right, so this is a functional approach to the top down. All right, now let's see whether this is effective from the recursive solution that we implemented. All right, let's rename a little bit. Let's change this to Fibonacci top down. All right, and time 1 difference 1 and time 1 minus start time 1 difference 1 and result 1. All right, now let's increase the value so that we can see some significant difference in the execution time. Okay, so we have made this to 40. Now let's run it. All right, meanwhile it is compiling. So what happens with the top down approach is, previously we were in every iteration it was evaluating since from the beginning for every loop, and that is how for a given large number of int it was running into a stack overflow or memory out of memory. But in this case it will be storing intermediate results in an accumulator which it will be using to evaluate the next value in the series, and finally we are only concerned about the last, that the optimal result. So we can see the difference. Obviously it's 5 folds that we can see, and eventually it is performant, but it is utilizing a lot of space here. Now in the next approach, that is bottom up, we will see how we can trade off with space and enhance the, or we can save on execution time, as well as we also can enhance our space utilization. So that would be the bottom up approach. All right, so if you enjoy this video, please like and subscribe, and see you in the next video. Thank you.